yani. Okay. So in this session we have talked about the feature of the what CNN application, but especially we will focus on the convolutional layer. Okay. So suppose that we have an image like a person, like this one. Okay, and we need to obtain in this form the regional information. What's the meaning of regional information? Suppose that we have the taking the hat values in here like this one, and so we can convolve this picture with some specific filter which is defined in the mathematical equations. Okay, and so the convolution is a what is a similarity rate of to what to function. Okay, or to object or to image, because the whole image contains the what, the 2D data, right? It's a matrix or 3D data, RGB code for each picture, and so we can convolve these pictures with the what with specific filter, and then we can generate the what, the new values or the new feature map by using this term. In most of the application we have the discrete convolution, especially in the computer. For the convolutional neural network application we always use the what, the discrete convolution, like this one, M, N, and I minus M and J minus N times, or the convolve operation in here like this one, and F, the M, N. Okay, this is the filter, this is the what, the image, and then this filter always convolve with what, with the specific image at the regional information for a specific kernel. Okay, and so we can generate the what, different data by using this function, right? And so in CNN we have some key parameters or the key feature to build this function. For example, the number of filters. We can build the 6 different type of filter in here, or 12 type or different filters, and so we can select the what, the filter types with what, with random initialization values. Okay, so we can give the what, the number or the size of filter, which we call the kernel function. Okay, for example, 2 times 2 kernel or 3 times 3 or 5 times 5 kernel will be applied on the what, the 1000 times 1000 image, or 224 times 224 picture, and so in each kernel apply the convolution and produce the 1 values at each iteration, and then we will have the new picture from this convolution. Okay, and also we have the 2 key parameters, the stride and padding, to be set in what, in your network. For example, if we have the image like this one, and then we have the what, the some kernel in here with the dimension of the what 5 times 5, and so we have the stride value in here like this one. Stride means that the step size at which the filter moved across the input. For example, if I said the stride is 2 and then the first stride value is 1 and then after that 3, this step taking to what 3 and then 5, okay, and then 5 7. And also we have the padding. Padding means that the empty space that needs to be filled with what, with our algorithm. We can use the padding as the what with specific dimension to be filled in here, because if we have this filter like this one, and so we can filter this nomination like this one, and so we don't have this space, but in a random number we can fill it and we can generate the what, the total number for a what, for this convolution operation. Okay, these two parameters are important for what, for your application. Okay, filters are the specific grid parameters for creating the kernel matrix to what, to be learned during training data. Okay, and so what is this kernel in application? We can build some codes in here like this one, internet, and we can build some basic codes in here to learn about how can we convolve this operation. Okay, and so yes, the word 1, for example, filter types dot py can be given in here. Okay, so firstly we need to import the some libraries, the OpenCV library in here like this one, CV2, to what, to utilize the specific filter, predefined filters in here. Okay, and also we can give the import numpy as np and import matplotlib.pyplot, matplotlib.pyplot as plt. Okay, and so firstly we need to define some specific function, apply convolution. Okay, firstly we need to get the input image in here like this one, and then we should give the kernel function, specific kernel function, or we can define this kernel function in here, and so the output image is equal to what, cv2 dot filter 2d can be used in here, the input image minus 1 depth and the kernel. Okay, this is the specific utilization of the what, the filtering to specific image. Okay, the depth is the what, minus 1, which means that there's no depth parameter in here. Okay,
What's minus 1 again?
Minus 1 means that we can convolve in different way, but in simplest way we can convolve each by one by one, and so we can set this value and then we can take the convolution number 1, number 2 and number 3, and we can assign the first term this collection of this one, and in the second step 2, 3, 4 collects the whole data, and then we can assign the 2 values. Okay, but in this case we will not use it. Okay, and so return output image. Okay, and then image can be assigned to cv2 in read function, can be utilized to what, to specific picture 1 JPEG. Okay, and this image should be retransformed to resize to what, in order to get the lowest values at the pixel. Okay, or the standardize the what, this picture values. Okay, and the image and we should give the sum tuple in here like this one, 224 in here. Okay, this is the simple operation to resize your image. In your application, maybe you made different size of the images, but in the first place you should resize your application or image in order to what? In order to create your training data. Okay, because you must feed to this data in the same input values. But you may take the 1000 times 1000 picture, or 70,000 times 70,000 picture. Two different size of picture can be used in your network, but only one condition, which is that we should resize your picture at the standard type of this assignment. Okay, so I can give some specific kernel definition in here. MP array can be defined in this nomination like this one. Okay, and so I can define the kernel like this one, 0, -1, 0. This is the standard definition of the sharpen kernel. Okay, and then -1, 5, and -1, and 0, -1, and 0. Okay, this function or this kernel function is standard matrix. Okay, but if I convolve any image by using this kernel, and then this kernel creates the sharpening image from the previous one. Okay, and so I also give the three kind of the kernel in here like this one. In the second place, the blur kernel, 1, 2, 1, and so 2, 4, 2, and 1, 2, 1, and divided by the 16. Okay, and also I can give another kernel in here like this one. This is the H detection kernel. Okay, 0, -1, 0, and -1, 4, -1, and 0, -1, and 0. This is the standard definition of each specific kernel in the literature. Okay, you may utilize the different kernels in here, but in standard application they are the most used kernel types. Okay, yes. Yes, Blur, for the Blur kernel we should utilize this kind of data distribution or the matrix. Okay, and so if I convolve this Blur kernel with the image, and so this picture get more blurred. Okay, and so I will show you that sharpened image like this one, apply convolution in here the image and sharpen kernel. Okay, and so we have the three kernel in here like this one, blurred kernel, this is the blur kernel, like, right, and H image and the H detection kernel. Okay, so you can visualize. Yes, this is the filter. Okay, this is the kernel function, 3 times 3, but I can choose the 5 times 5 sharpen kernel in some conditions.
But you said the filter is trained inside. Filters are trained inside.
Yes, but this is the predefined filters. But in convolutional neural network, these filters should be learned from the future, because if you put or feed the some specific image, and so this kernel should be learned by using the back propagation rules. But you can utilize also this kernel in your convolutional network. Okay, I will show the both of them in here. Okay, and so plot figure and fixed size can be given 12:4 like this one. PLT subplot can be given 1:1. Okay, PLT im show and CV2 CVT color. This is the standard transformation to what image. CV2 color BGR to RGB. Okay, and so this image converted to what? To RGB values from the BGR1 binary grayscale resolution. Okay, and so if I run this code and then I don't have any picture because the load show must be given, right? Okay, this is our guy. All the times we use that guy. Okay, Detaylı. Original. This is the original picture. No, this is the original picture. Okay, and so we can give the what like this one, and show 1:2 and the CVT color and sharpened image and PLT title sharpened. Okay, in the third case we can give the blurred, and in the fourth place we can give the what? The H, right? H image, H. And so if I run this code, and then we will have this kind of picture output. Okay, this is the original picture and this is the sharpened. The pixel get more the sharpened, and in the blurred, and we have this kind of blurred image, and in the H detection, and so all the tones are diminished in here, are removed, and only the H can be more observable. Okay, this is the standard input filter to what? For example, to detect the H detection. And so if we want to detect or classify the H in here, and then we can utilize this H information in here, right? Okay, okay. And so how can we utilize or build the convolutional neural network model? By using this information. So in the second place we are to come to the keras.py. Okay, so from keras.models import sequential, okay, and the model like this one, and from keras layers import con 2D. This is standard function to what? To create the convolutional layer in your what? The convolutional neural network. Okay, and so from keras pre-processing image and import the load image and the img to array function, because we need to feed all the data as an array format in here, not the RGB values. Okay, and also we can visualize the whole data by using the matplotlib pyplot as plt. Okay, and so in the first place we should assign the image, the load image, like this one, the picture 1 JPEG. Okay, and so the target size can be given in here like this one, 224 224. Okay, and in the second place we should assign the input image like this one, image to array the image. Okay, if I use this information, and then we can convert the whole image as an input image. Okay, this is standard application, and so in your application you should utilize these values for the what, for each image. Okay, no, load image represents the what, the target size 224 224, because this image has the possessed what, RGB values, but these RGB values into the what should be translated into the what, the input image 224 and 224. In the normal place we have the 224 times 224 matrix with the what, with the 3 elements, red, green and blue. Okay, this is the higher dimension. In the second place we convert to the what, only 224 and 224. Okay, yes, 1. So you can create the model in here like this one. The sequential can be used, and also from Keras models import. It's not necessary here. Conti. Okay, and so model.add. This is the standard definition of the what, the model adding to the what, some features in here, and so con2d function can be given in here. Firstly, we need to give the filters parameter in here 16, and the kernel size should be defined with the what, for example 16 and 16 times 16 kernels, or the function is initialized in here, and the input shape should be given in what, 224 224 and 3. Okay, and then we should give the what, the activation function as a real. Okay, so we can add another filter in here like this one, the 8. Okay, and also we can give the 8 and 8. Actually, in the first place should remove this one. Okay, the second place we can add this model. Huh? Yes, but in the first place I will show the simple example in here. Okay, and so in order to compile this model we should create the optimizer in here like this one, the ADEM, adaptive moment estimation, and loss function should be given as the categorical cross entropy. Okay, and then we should give the metrics in here in terms of the what, the accuracy. Okay, so PLT figure should be created in here like this one, 5 and 5, and PLT im show should be utilized to what, the input image with the normalized value 255. Okay, this is just the normalization of your data. It's given in here. Okay, 0 to 255 is equal to what, the whole branch of your picture. Okay, so the PLT title should be assigned to what, the original picture, right? Okay, and so if I run this code I can only show the what, the PLT show should also be given in here. Okay, fix size Okay, this is our guy. What's the dimension of this thing? 224 times 224, right? Yes. And so after that we can visualize all the layers in here, like this one. This is the predefined function, the layers dot output can be given for layer in model layers. We have obtained the whole the layers in here because we need to show the whole the layer output at each one time. Okay, and then the activation model also given in here. The model, the inputs should be given in the model input like this one, and the outputs is equal to the what? The layer outputs. By using these terms we can obtain the each convolutional layer output, not the total output. Okay, each model layer produce a specific image like this one. Okay, and so displaying the whole the function, we should activate all the functions in here like this one, the activation model, and we should predict the whole the data in here like this one, input image reshape function like this one, 1 2 2 4 2 2 4 and 3. Okay, it's the 4-dimensional data in the activation model. Okay, because we need to create the every convolutional objects or the layers in the first place. 1 2 2 4 2 2 4 and 3, the RGB code should be given in here because we should define in the colorful form to analyze it. Okay, I can build it, or I can build in the what? In the grayscale format. Okay, and so now layers can be given in here like this one, then activations. Okay, and so PLT figure, the fixed size should be equal to the what? 15 times 5 times num layers. This is the adaptive layers, because if we had the one more convolution and then we add the some subplot in here. Okay, and so after that for loop can be given in here like this one, layer ID X and layer activation in enumerate activations. All the features is assigned to the layer ID X and layer activation like this one, and num channels can be defined in here, layer activation dot shape -1 is the default value, or the no depth in here. For the channel ID X in range num channels, because the R limit in here, for example, we have the 16 filter in here, and then we should fill the 16 filter into the what? Into the one row. Okay, just simple. So PLT subplot can be assigned to the what? The num layers and the num channels and layer IDX times num channels plus channel IDX plus 1. Okay, this is the simple identification of what? The row 1 and num channels is the column values, and 1, 2, 3, 4 is assigned at each direction. Okay? This may be complex, but it's simple. Okay? Just accept right now. And then PLT im show can be written like this one. Layer activation can be called with what? The 0 element. And whole feature of the height and width, and also we give the channel ID X, and the C map should be assigned to the grayscale. Okay, and after that PLT title F L layer ID X and C channel ID X plus 1. Okay, so and after that PLT show this code all this time. Okay, so if I run this code right now, and if there is no error in this code, layer activation 0, there's the channel IDX, C map gray, right. There is some error in here. Num channels, next time num channels plus channel IDX, yes, plus 1. Okay, and plot title F layer IDX channel IDX plus 1, yes, and so num layers activation and num layers 15 time. Okay, here layer activation and activations. No. It's a runtime problem. Huh? Yes, it's an index error, but cannot identify channel IDX, layer IDX, layer activation. So no, it's all true in here. Okay. Could be. It's kind of error can be given in here. Okay. This is the higher dimension in the data. Okay. And see if there is one term, and so this layer is represented 3D dimension, but 4 required. Okay. In this code, just remember that this code should be given in the what? In the form of the higher dimension or the higher representation. If we have the one convolutional layer, and so one column is enough, and this is called to the what? Unnecessary part. But in the channel IDX there is what? There is unnecessary data, and so this could be an error. Okay, and so if I run this code, and then we will have the what? Okay, this is the original picture. Okay, but this is our convolutional operation, and so layer 0 convolution 1 produced this image, channel 2 this image, and so we have the channel 16 in here. Okay, and this is the what are different maps to what? The convolutional operation. But just remember that this coefficients is not trained right now. Okay, this is random values, not the sharpen, not the anyone else. And if we train the convolutional neural network, and this may be changed. Okay, but in each convolutional operation we generate this picture, and 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 after that, these values is fed into the what? Into the another layer, like this one. And so these channels produce, in the second place, we have this convolution. This one, this one, this one, this one, this one. And so each picture are different from each other, right? Okay? And so if I build another one, filter 4, like 4 and 4, and so if I run again this code, and then we will have the 3 layers in here. Like this one, okay? So, by using the convolutional layer, we produce the one image from the 4 picture. And so we enrich our data representation by using these terms, right? Because this is the huge advantage of this thing. Because in the first place, we have the 224 times 224 data is contained in in the one image. And so this is the input data. But by using the convolutional layer, we can generate unsupervisedly the more data representation from one picture. And so we can enrich and improve our classification performance by using this data representation. But in the visualization and in the showing operation, and so we will get these outputs before the training. If we train the neural network, and then this picture may be changed. Okay? Do you understand the convolutional operation in here? The representation of these things, right? Okay? This is what the kernel function applied to this picture, and the picture generates the new outcomes. Okay? And so this is how we can change our whole data and increase our data, augment our data by using convolutional layer, right? Okay. So, do you need a break? Yes or no?
Yes.
Yeah, okay. Let's take a 5 minutes break.